Okay, we're back for section 5, where we're going to discuss in-house manufacturing, but now in a build-to-order model, significantly different than build-to-stock. Let's see why. In a build-to-order model, manufacturers still have to engage in manufacturing planning and control off of a forecast. The reason why being is that we have to have a baseline from which to work. However, and this is the big distinction, actual production only takes place when an order is received from a customer. We are the manufacturer. We have certain capabilities. We're not going to do anything in a production sense until we get an order from a customer. We're not building to stock off of a forecast and sticking goods in a warehouse. We have a forecast because we need a baseline from which to work and at least do some planning. For example, have a certain amount of raw materials and inventory in anticipation of customer orders. But our thing is we don't lift a finger to make anything until we get an order. Think about this for a second. This model forces manufacturers to be much more sensitive to variations in the forecast. Of course, we're going to start with a forecast, get us rolling, provide some planning baseline, but we have to be very sensitive to the differences between forecasted sales and actual sales orders. That is another big difference between build-to-stock and build-to-order. This sensitivity around the need for raw materials based on orders drives our whole inbound supply chain of raw materials. Typically, build-to-order manufacturers at least make an attempt to carry no finished goods and lower amounts of raw materials inventory. We're going to need some raw materials laying around, especially since if we're buying from overseas vendors, lead times are such that we might have orders and don't have raw materials to go into production. That's just another example of a balance between the needs of the marketplace, customer orders in this sense, and how much we invest in inventory. For sure, build-to-order manufacturers, they don't want to have finished goods, but they realize they're going to need some amounts of raw materials, especially in our case, where we are the manufacturer in the U.S., but we're bringing in raw materials from overseas. The timing is just too risky. Build-to-order also requires that manufacturers have much tighter scheduling for the purchase of those overseas raw materials. A balance between actual orders received from customers, what we have in raw materials inventory in-house, albeit in a limited amount, and what quantities do we need to get from overseas suppliers, how quickly do we need them, and what is the cumulative lead time of each raw material. That's where things get really tricky in a build-to-order model. As a build-to-order manufacturer, yes, we're driving down our investment in inventory, but we're putting ourselves at risk from the sense of being able to meet orders when those customers want them. If a customer wants an order delivered in 30 days, and the cumulative lead time for our most important raw material, which we don't have any of in inventory right now, is 45 days, that's the problem right there. So that balancing act is really tricky for build-to-order producers. Another thing to consider is that this model may also imply smaller purchases of raw materials, but with greater frequency. We're getting orders from all different kinds of customers for probably different types of products. Maybe the same product with different configurations, but different customers want different things. In that sense, we don't want to make huge purchases of raw materials because we run the risk of investing too much in those raw materials. The solution, sometimes, is to buy in smaller quantity, but with greater frequency. More purchase orders being placed on our international suppliers. This requires a special focus on minimum order quantities from those overseas vendors. An MOQ, as it's called, that's the minimum amount required to buy from a vendor overseas, regardless of how much we need. We might need only 500 units of a given raw material for a specific customer order, but the MOQ from the vendor is 1,000. That's another consideration we have to deal with. All of these factors have serious implications for policies, procedures, and key performance indicators, KPIs, related to sourcing, purchasing, and inbound logistics. You can see from this slide, as well as previous slides, we're starting to talk about in the same sentence sourcing, purchasing, and inbound logistics, the integration of inbound supply chain activities. From sourcing, where we're going to buy goods, from whom are we going to buy them? Purchasing, the actual placing of purchase orders for raw materials on selected vendors. And how do we support all of that, especially in a build-to-order environment with inbound logistics? If our inbound logistics isn't optimized, the raw materials that we need to go into production can get stuck at origin. The vendor's late in producing, or there's a quality problem with an order. We can't get a sailing from origin because of peak season congestion. Goods get stuck in customs. Many different ways things can go wrong for inbound logistics that's going to impact the ability to produce on a build-to-order basis. These are some of the reasons why companies choose to engage in build-to-stock, because they understand the risk of carrying too much inventory. But past experience has shown them that build-to-order, depending on the nature of the business model, just might be too risky for some manufacturers. It all depends on the model itself, a company's fundamental philosophy, its aversion to risk, its financial capabilities. Can they even invest in lots and lots of finished goods? That's a consideration too. Once again, we're not here to tell manufacturers to engage in build-to-stock or build-to-order. We're here to point out pros and cons. We will say that build-to-order, especially for importers buying out of places like Asia, is a predominant model that has to be dealt with. In this slide, we're going to move on and talk about assemble-to-order models. Little bit different than build-to-order, but some similarities along the way. As the name would indicate, assemble-to-order operations do not deal in raw materials-based production. If we engage in assemble-to-order, we're still importing materials from overseas, but in this type of model, manufacturers carry inventory made up of components and sub-assemblies, things that are ready to be put together, basically. Sub-assemblies, components that don't require manufacturing in and of themselves. Just think of the name, assemble-to-order. If we operate that type of environment, we're waiting to get an order from a customer, and then we're going to assemble these sub-assemblies pursuant to that order. Let's wrap up this slide and emphasize that, like the previous two models, build-to-stock, build-to-order, an assemble-to-order production model also operates off of a forecast. Because we as the manufacturer, as the assembler, we need a baseline from which to work. The actual orders that we receive are going to consume that forecast, to use a term we'll get to further down the road, but the forecast has to be there from the beginning. That forecast drives the acquisition of the components and subassemblies that we need, bearing in mind that it's the bill of material and the exploding of the bill of material that tells us what we need and in what quantities. The BOM in this particular model is going to be based on those sub-assemblies. With that said, and we will reiterate here, this type of model very dependent on the receipt of customer orders, because assembly only takes place when orders are received, whether it's an industrial order that's placed on an actual salesperson, somebody goes online and buys a couple of laptops. The source of the demand is important, but what's really important for this bullet point is to say that, like build-to-order, assembly only takes place when orders are received. Same thing in assemble-to-order. The rationale being that this approach allows for greater customization of final product. We'll talk about this in just 1 second, but imagine if someone goes online to buy a laptop or a tablet, something that has different features. How many USB ports in a laptop, as an example? A buyer, an individual person, can go online and configure how they want their laptop to look, what capabilities they want their laptop to have. That's customization. Customer orders, the customization of customer orders, and the assembly process all must be integrated. Last slide in this section, we'll wrap up with assemble to order. This is very similar to what we saw in build to order. The lead time for customer orders resonates up the supply chain and is reflected in purchasing policies with overseas vendors. We, as an assemble-to-order producer, we are going to need a certain amount of raw materials of those subassemblies and components. We can't not have anything, especially since we're buying overseas and the cumulative lead times are longer. We have to have some kind of inventory around. Depending on those inventory policies for components and subassemblies, inbound transportation can be a combination of ocean and air freight. This is where a good tie-in exists between production models and the inbound logistics that supports the transportation of raw materials come together. Ocean freight takes longer than air freight. Hopefully we all know that, but air freight is much more expensive. But if we're only assembling based on customer orders and all of our subassemblies and components are coming in from overseas in ocean containers, might the timing just be too long and we need to move goods by air freight to be able to respond quicker? That could very well be, but of course, a shift to air freight from ocean freight implies greater expense, which impacts what? The landed cost of the product. We need to be cognizant of those things. Let's wrap up this slide and say that assemble-to-order models have historically been more prevalent in high-tech and consumer electronics. A good example of bullet 3 is Dell Computer. They have manufacturing sites in the United States, but what they really are, and they're to be commended for this, are assembly sites creating U.S. jobs. That's a good thing. What they're doing is receiving orders, lots of them online, by the way, and assembling to the specifications of individual customers. They have some subassemblies, components, and such in raw materials inventory for sure. They're assembling those based on orders. How they continuously replenish their raw materials in an assemble-to-order model is tricky stuff because most of those subassemblies and such come from overseas. And that's why you'll see a Dell, for example, use a combination of ocean freight and air freight. That's it for this section. So we've wrapped up a good conversation around build-to-stock, build-to-order, assemble-to-order, broadened our frame of reference, if you will. Now, when we come back, we're going to talk about the characteristics, the general characteristics of the forecasting discipline and how that is going to impact us as a manufacturer of finished goods based on the importation of raw materials. We will be back soon.